Yeah, so in yesterday class, we had seen like different match and merge rules, right? Different match rules we had created, and we had done consolidation process, like we had merged some data, and before that we had found some match candidate before doing the merging with the help of different tokenization option, right? So this part we have completed. Now in today class, we are going to see same things, like we will develop some more complex match rules, and we will try to see the output. So in yesterday class we had taken only a one table, like a root table, that is employee table. Now in today class we are going to take one more table, so that we can understand the how actually things happen in the real time, because in real time environment you know that there will be multiple tables, so you have to connect all the tables, and you have to write appropriate match rules, so that you can find the best match candidate. So let's start the thing. So in yesterday class, if you come to match merge setup, so in path we had not added any more up tables, we had only PEMP tables, and already we have covered like how to what is exact match, what is fuzzy match, right? How to add the exact match and how to add the fuzzy match columns, and what are different keys, right? So this part we had already covered in the previous class. So in today class also we are going to do the same thing, but we will add some take some one more example. So we have the employee table, right? So let's check that do we have any kind of relationship with this employee table or not. So we don't have. So let's try to create a one address table. Let's create a one address table, like L underscore ADR. So what I'm trying, I will put address ID as a common key in between this address and employee. And suppose like if you are not able to identify the person with the person name, then of course you will go for checking the address, right? Like if the person is having the same name, and if you will compare the address, then you can identify that these two persons are same or these two persons are different, right? Maybe you need to compare more columns in real time. So how you can add the other tables, and how you can define the better match rules. So for that we are going to create one landing table, like that is address landing table. Let's add some table columns. Let's add address ID as a primary key. Let's add address line 1. Let's take a state code, and let's take a zip code, something simple address table we are taking. Fine, let's save it. Now let's create a base subject table for address. B underscore ADR. Now let's add the columns, like address ID. We can add ADR line 1. Then we can add a state code, state code. Sorry. Let's add a zip code. Let's save it. Let's make this address IG as a unique, so that we can define relationship on top of this. So yeah, you need to disable it before making a unique, then it will allow you to make a unique. So now let's try to make it unique and save it. Now also let's change something in the stage table. So Yeah, let's create some stage table for address. So like this is s underscore adr underscore source system 1. Let's select all the columns. Okay, let's select the address table for source system 2 as well. S underscore adr underscore src2. So we have two address tables. Now let's define a mapping for this address. Sorry, mapping underscore adr, that is for source system 1. Let's select landing table for address and a stage table for address. Now let's create another mapping for source system 2 of address. So s underscore address for source system 2. Let's select the landing table and source 2 stage table. So now we have created two mappings for address. Now let's configure a mapping part, do auto mapping. So here you can see your zip code is mapped, state code is not mapped. So yeah, something wrong, we had taken a column like ST something, so that's not a problem. So maybe like your landing table and the stage table columns could be slightly different, so you have to manually map that field, okay, if there is some difference. So you are passing zip code to zip code, a state to a state, address line to address line 1, last update date to last update date, and let's map this address ID as a PKSRC object. And let's give some filter condition, because we know only we need only source system 1 record, source system equal to src1, validate it. Okay, I think this column we have not added, so that's why if you save it, src system column we have not added in landing table, that's why we are getting this invalid error. So let's come here, let's go to address, let's go to columns, and let's add the source system column here, so that we can identify the record from different source system. Fine, now let's come to where we was. So yeah, we were there in the mapping, right? So now see, the if you will validate it, so now it will be validated, because this column we don't had, and we had applied some filter, that's why we are getting some error, right? So now it's fine. So now same thing let's do for this mapping. Let's do auto mapping first, and here you can see a state code is not connected. Let's map it manually, and let's do one thing, and let's map this address ID as a PKSRC object. Let's save it. So now let's first populate the data in base object of address. Okay, so let's create some test data in address table, landing table, so that we can load the data in base object. So let's come to address landing table. So CL address, here this is, click on data. Now let's add some test data. Let's take last update date as today date. Now we can take address ID. Let's take address 1 as a one address ID. Address line 1, let's take suppose something. I'm taking the address of New Delhi, Rohini something. A state code, let's take this as a Delhi. Zip code, let's take 110085, and source system, let's take source system 1 for this record. Let's create a same record for source system 2. Let's take address ID of this record as ADR2. Let's give some address like New Delhi, Rohini, something. Let's take a 1 to something, some small difference. Let's take a state code as the same. Let's take a zip code as the same, 112085, and let's take it as a source system 2. Let's save it. Now we have inserted some data in the landing table. So now we can run the mapping to load the data in a stage table. So now go to batch viewer. Now go to a stage process. Now let's run the mapping for source system 1 first. So execute batch. So here we saw that one record inserted. Let's verify this record. So in real time also, maybe you will have millions of records. So at least try to verify 1 or 2 records, so that means you can see that are you missing any columns or not. So we have loaded for address source system 1, right? So we are getting PKSRC object fine, and here we are getting address this. All the fields are populating fine, right? Perfect. Now let's run the second mapping. SADR SRC2, so that we can get the data from source system 2 to the stage table. Oh sorry, here you can see that 2 record got inserted, because I think we have not applied any filter in second mapping. I think here we have not applied any filter, right? So that's why it also means populated the source system 1 record, right? So always provide the appropriate filter, so that you can only read the respective source system data. Source system equal to SRC2. Let's validate it. Let's save it. So we got wrong data in stage table of for source system 2, right? So we have no need to truncate that table. We no need to truncate this table, as you know that this is a stage table is a truncate table, right? So we can directly run the second mapping job. Now we can directly run this. So now this time we received only 1 record from source system 2. You can also see that the address ID of this record should be SRC2, ADR2, right? Sorry, this is. So here you can see ADR2 record we received in the second stage table, and all the fields are coming perfect. That's fine. Now let's run the respective load job to get the data in base object. We got 1 record inserted in base subject. Let's verify it. CBADR. Here row ID object is 1. That's fine. And here we received address ID, address line 1, state code, zip code. All the things we received perfect. Here you can see how a state indicator is 1, that is active by default, and consolidation indicator is 4. That means this record is a new record, fresh record. The same entry you can see in XREF also, along with PKSRC object, right? Now let's run the second load job. The second load job is SADR SRC2. So this time also 1 record got inserted. Let's check it. So we received the second record for row ID object 2, and we received the address ID, address line 1, state code, zip code, everything is fine, right? So that's great. So we finally loaded the address table. in the base subject. Now let's think about the employee table. Now come to a schema again. So in address we have added address ID and we want to apply relationship on the basis of address, right? So if you want to relate this address table and employee table, so first of all let's add the address ID column in the employee because you don't have address ID. So let's add this column. So before that we also need to add this column in landing table, right? Because from landing table we will create some test data and from there we will load into the base object. So let's create this, add this address ID in landing table as well. So ADR ID, let's save it. Let's add the same column address ID in the base object of employee. Let's add here. Let's add the same column in the stage table. So in a stage table, let's select it and let's save it. Finally, so we have added the address ID. Now let's try to define the relationship. So that click on plus, select address ID from employee table. This part already we have covered. So and select the, here address ID is visible because we had made address ID as a unique key in the address table. That's why this is visible. Otherwise, only by default row ID object and PKSRC object will be visible. Fine. So let's take this address ID. Let's make a simple relationship. Relationship got created. Now let's try to write some match rules. So here, now come to path. Now let's try to add this address table so that we can extend our search logic. We can extend our match rules, right? So let's give like this is the address table. So let's give any name like area something. So default it will create some physical name something like this, CMT address, that is the match address, and here we are defining child to parent relationship. Press OK. Now you can see here we have added one more table with this employee table. So this BEMP is a kind of truth table and this B address is a second table which got added. So what is the advantage of this? So like previous we had only employee table columns available for defining the match rules. Now we will have the flexibility to add the address columns also for writing the match rules, right? So our match rules flexibility has been increased now. Yeah, so let's try to add some columns here. So here you can apply filter like in real time. Suppose if you want to do some testing, so you cannot means run the whole job for the millions of records. So here you can get some kind of some like on the basis of some ID like on address ID in not in something, and you can add some ID here like if you want to add like 10 something, then you can add this ID here and that ID will be only selected. So you can apply some filter here if you want. So come to match columns. So in match columns till now we only have the columns of, here you can see source table is EMP, right? And in path component earlier we only had EMP, but now if you will click here address will also be visible. So now we are ready to select the columns of address also. So now let's add some exact match columns and some fuzzy match columns. So let's add one exact columns. So here by default you can see this all the fields are coming from employee table, right? But you are trying to add some more columns of address. So just go here and select the address. Then it will show the address columns. Earlier we don't have, right? So now we can see the address columns. So now you want to define some what we say, we are defining exact match, right? Exact columns. So now let's select a state code. As per your requirement, you know that you can select many columns as per your requirement. That's not a problem. So for this POC only we are selecting this zip code and address line 1. Let's add this. provide a display name. Yeah, so in case of exact, we know that we need to provide the field name, right? So let's give ex for exact, ex, and that is a state code. So give the meaningful field name so that you can identify like what information is there inside this. So here we have ex state code. So here you can see only state code columns has been selected. But if you want later, you can add more columns as per your requirement, right? From here you can add. You have no need to add more columns. Okay, from here you can edit this field name. Let's save you. So let's add one more fuzzy match columns. So just we have added one exact. Let's for fuzzy match we need to click on here blood plus sign. Now let's select the address table from here. And now in the field name, as we know that in case of fuzzy, we have no need to give the field name, right? From here we have to select the appropriate information so that MDM can apply a respective algorithm what it had in the backend. So what the data we have, like let's select this ID and let's select this zip code, because zip code is related with ID. Let's see that it is allowing or not. So in ID we have taken the zip code, right? Because zip code is something a numerical value we have. That's why I have taken the ID. Fine. So just we have taken these two fields. Here you can see in the source table this is saying B address, right? And this is BMP. So from here you can see like which field is coming from which tables. From here you can see. Now let's come to match rule set. Let's delete this. Yeah, now let's try to define some match rules. So we are going to define fuzzy match rule. In fuzzy, let's take as you know that in case of fuzzy, we will have both the options, like we can select exact match columns also, and we can select fuzzy match fields also, right? But if here you can see, like if you are selecting fuzzy, so here exact match columns are also available and fuzzy match columns are also available. But once you select exact, then you will see only exact match columns will be available. Fuzzy match columns will not be available. So in fuzzy we have a flexibility, but always remember that fuzzy is a very cost means as part of performance, that is a very time taking process. So always be careful while selecting the fuzzy in real time. So here let's take a person name, and I am taking person name from employee table, and I am taking the state code. A state code from this is coming from the address table, and combining this, and what this is saying, yeah, wheel card we need to select here. So let's select the match purpose. Let's select the field here. So here we know that if you want to make this match rule as a auto merge, or means after the match, if you want to send that match candidate for the auto merge queue or manual merge queue, here we need to make the change, right? So here this auto value is no. That means that is not a auto merge. The record will not go to the auto merge queue. The record will go to the manual merge queue, right? So yeah, let's same it is, and let's keep the means we want the record to go into the manual merge queue, right? Now let's save it. Let's reset our match tables. Fine. So we have done the match rule setup perfectly. So let's do one thing. Yeah, let's first means see these things. Then in the second example, we will do some trust setting and we will see the output. Let's see the output of this first. So here we need to create some test data in employee table also, right? So let's create some test data in landing table of employee. This is a landing table of employee. So here we already have this much of data. So let's give here address ID something so that it can find something. Let's take this record is belonging from this address 1, and the other records are belonging from address ID 2. So let's we have edited the data. Now let's try to save it. Yeah, so what the data we had in employee table, just we have added some address ID, and these all address ID are already present in address. We have not taken any third means other address ID which are not present in address, right? Because we have defined relationship. So maybe that this address are will not be present, then we can get some errors, right? Some rejection can happen. So fine, now let's run the stage job for employee. Before that, go to mapping and verify the mapping for employee. So go to mapping, go to diagram. Here you can see we have just added address ID. So let's pass this address ID to the target, and all the things are same, right? MP name is coming to MP name, MP ID is coming to MP ID, and MP ID is going to source PKSRC. That's fine. So now our mapping is ready to load data from landing table to a stage table. So let's go to batch viewer, and in batch viewer now let's go to the stage process. For a stage, go to the stage process of employee for source system 1, and let's execute it. So the today date is 2nd. Which log is for today? I think this is. So receive 2 record. Let's verify this record in the stage table of employee. No, so we are supposed to get 6 record, right? So we have got the 6 record. So I think that was not the log for today for this batch. The log should be something October 26. I think something this. But today is November 2. So where is the log? Yeah, this is the log for November 2. So here we got the 6th record inserted in the stage table, right? And we can see the 6th record here. So at employee ID, at employee name, and address ID, these all are coming perfect. Fine. So we have loaded data in a stage table. Now let's try to load data in base subject. So for base subject already we have done the configuration, like what we say. We have already defined the match rules. So match rule, this match rule is not is connected with this load process, right? So let's run the load job first. So after getting the data in base object, then match and tokenization things will come in picture, right? So this is saying no action for 6 record, okay? So I think this 6 record was already there in base object. So we need to truncate the base object. For EMP, here you can see for last updated 1st November for yesterday, the records was already there. So let's remove the record from base object. And then we will get the fresh record. And also we need to remove from xref table, right? Let's truncate this table. So xref, sorry. So BEMP is clear, xref is clear, strp do we have something? Nothing. MTCH clear, everything is clear. Now let's run the load job again for this employee. So we got 6 record inserted this time, right? Let's verify this 6 record in base subject table. So we got some row ID object which was generated by MDM, and we got row consolidation indicator 4 for all the records. And here you can see hover state indicator 1 and employee ID, employee name, these all the things are coming perfect, right? So here we have defined a relationship on the basis of what is a address ID. So let's make some kind of here if for address. So how the actually matching will happen if we are going to run the match process or tokenize process? So how it will find the match candidate? So let's do one thing. Let me copy these all the records on the Excel.
That's really fun. So I understand maths. I didn't understand tokenization. Can you give me 2 lines about tokenization? What it is?
Yeah, I will give. Once I will come there, I'll give that. Just let me explain this. So we have employee data, this data, and let me copy the address data. So we have only 2 record for address, this one. So here we have defined match rules. We are trying to find the match candidate on the basis of employee name columns of employee, and on the basis of, let's check it, what the match rules we have defined. Come to a schema, come to match rules, and here you can see the match candidate. So we are defining a state code. We are taking a state code and person name, right? No, let's take a, what we say, not take a state code. Let's take a, yeah, state code is also same for both the records, right? So that's not a problem, you can take it. So here you can see the state code is same for both the record. So if it will do kind of join inside that at the time of loading the data in relationship. So for this 3 record address, the address ID is ADR1, right? So it will try to take the this state code Delhi, and for this 3 record it will do join on the basis of ADR is 2, and in that case it will take this address. So in both the case we have taken the same address so that we can get some match candidate, right? So that's fine. Now let's now let's try to run the tokenization. So as you know that here we have defined some fuzzy match columns, so we need to run the tokenization. So let me recap for 2 minutes what is tokenization. So see, if you are defining some fuzzy match logic, so fuzzy means you are not confident that your data may be similar, 100% similar. That means you are going for the fuzzy match logic. So in fuzzy match, maybe your data could be exact 100% same, or your data may be partial same. So with the help of fuzzy match, we can get some match candidate. But if you are not defining fuzzy match, if you are going for exact match logic, then if your data is not same, then you cannot get any match candidate. So the fuzzy match is having a more flexibility. That's why most of the time in real-time project, we do use a fuzzy match. And as part of performance, fuzzy match is more cost effective. So always try to avoid a match and means write a more complex rule for fuzzy match, so that it can take less time. Okay. So like for fuzzy match, we know that some of the records which could have a dissimilarity or which could have a partial similarity, right? So what MDM does, MDM has applied a concept of tokenization. So before comparing these partial matching records with each other, they generate the match tokens. So match tokens are kind of some algorithm has been defined inside the MDM, and what the configurations we are doing here, like if you are coming to match columns, what the different key width and key type we are selecting. So on the basis of this configuration, MDM will generate the appropriate tokens. Like maybe for one record it can generate a 4 to 5 tokens, 10 tokens, 100 tokens also. If your a string is larger, then in some cases it can generate the 100 tokens also if you will take the extended, right? So it will generate the kind of different representatives of the same record, and in place of matching the actual record to each other, it will try to match the tokens to each other. It will not match the actual information, it will match the tokens of the information. And maybe the tokens of information could not be exactly same, so the tokens are getting generated by MDM with the help of some SSL algorithms, and that 2 tokens can communicate each other. That 2 tokens can be comparable each other with the algorithm which has been defined in MDM. So if you will see like these tokens, let me run the tokenization job, then you will see that for each record we will get some tokens. So let's take here a standard. This is a, what we say, this is general key width which we take in the normal environment. So let's save it. Let me generate the match tokens so that you can understand. Like we have a 6 record in base object for employee. So you will see that for this each and every ID object, it will generate some match tokens. So let's go to batch viewer and let's try to run the generated tokens. So for that, go to generate match tokens procedure and generate match tokens for employee. Let's execute it. So for generating the tokens, we have to run this procedure. So here you can see record tokenized 6 means we got the tokens for 6 record. So where that record will be stored? So we know that that record will be stored in the strp table. Come down. Here you can see this is a one strp table. So from here you can see the tokens. So let's arrange it. I think this is already arranged. Yeah, so here you can see for some of the record for this like a 6001 something, it has generated only one token. For 2, 1. For 5, I think this is not arranged. Let me arrange it. Yeah, so for 2 it has generated 2 tokens. For 2 also this is 2 tokens. For 3 it has generated 1 tokens. Why? Because 3 is having a employee name as Sujit only. So this string is small as compared to Sujit Patel or Sujit Kumar, right? So that's why it has generated only 1 tokens for this row ID object. So if a string will be larger, more larger, it may generate 50 or 100 tokens also. So for 4 it has generated 1 tokens, for 5 2, and for 6 1, because 6 for 6 also the employee name is Sujit, that's why it generated 1 token. So as per the means length of the string, length of the information, it will generate the different tokens. So in tokens it keeps the information about SSA key and SSA data for each row ID object. So this SSA key and SSA data will be generated by Informatica MDM algorithm. So what the configuration we are doing here, what the key type and key which we are taking, accordingly appropriate what we say algorithm will be applied in the backend once we run the tokenization process, and that tokenization record will be generated. So this much of tokens we received for each and every record. Now if you will run the what we say, now if you will run match process, so it will try to find the match candidate on the basis of these tokens. Now MDM will not go to it will not see the actual record, it will see the match tokens, and on this basis it will try to find the match candidate. So now let's go to run the match job and let's find the match candidate. So for that, go to batch viewer, go to match job, BMP, let's run this. So here this is saying we received the 7 match candidates. So here this 7 is not a number of records, here the 7 pairs we received, right? So you can say like yesterday we discussed, like here the number of records are 6, like we had only 6 record, but why we got the 7 pairs? So maybe like see, like if you have 1 2 3 4 5 6 records, so maybe record 1 can match with 1 also, with a 1 also, or with a 2 also, with a 3 also, or with a 6 also, right? So there is a probability of matching the same record with the multiple records. So that's why the number of match pair could be larger as compared to the number of records. So this thing will be more clear now if you come to MTCS table. So where the match candidate information will be stored after running this match job, where this match candidate you can get like which got merged with which one. So go to MTCS table, here you can get the match candidate. So here you can see the row ID object, and here you can see the row ID object match. So 3 is matching with 1, 4 is matching with 1 and 3, 5 is matching with 2, and this 6 is matching with 1, 3 and 4, you can see, right? So as per your information, it will find the match candidate. If you want to verify, you can verify it with the actual record, like why this is matching with the 3. So let's verify 6, 1, 3, 4 and 6. Go to base object table, let's see the row ID object 6, and let's see the 2 information. Like here you can see employee name is Sujit, and as you know that state code is Delhi for ADR 2 also, right? And if you'll see 1 3 and 4 for one record also, we have SUJEET. This string is common, so that's why it found the match candidate. For this also it found the SUJEET common, and for this also it found SUJEET common. So that's why it identified these 4 records could be the similar record. So that's why it found the 4 match candidate, right? So you can verify your records after running the match job. Maybe that in real time, maybe you can see that you are getting the wrong match candidate. So you can optimize your match rules accordingly. You have to change your match rules accordingly to get the correct match candidate. Fine. So we have got here our match candidate in the match table. Now you can so from here you can confirm here auto match indicator is 0. Why this is coming 0? Because in match rules we had configured manual. Here you can see in match tables we have taken auto match in no. That means it will go into the manual merge queue. So that's why we are able to see auto merge indicator as a 0. That means this record will go into the manual merge queue. So if you run what we say auto merge job, like if you want to merge this record with the help of a job, if you are running this job for employee, then I think that it should not capture the record. It is saying auto merge record 0 because the no record was captured in the auto merge queue. That's why the auto merge record was 0. And here you can see accepted a unique record. So two record don't had any match candidate. So we had done the configuration here. Here, like accept all unmatched record as a unique. We have made it a yes, right? So what it will do, if it will not find any match candidate, then at the time of merge, it will make that record as a master record, because for the maybe for the some record we could not get any match candidate, right? Maybe that would be the new record in the system. So for that for one record there will not be any match candidate, so that record will become the master record. So let's go to the data managers. Yesterday we had defined some query and packages. And here you can see for two records, the two records which don't had any match candidate, that got merged, and we got the consolidation indicator as a 1. So now let's do one thing. Now let's change the consolidation indicator. Let's Q for merge, and let's put Q for merge, so that we can get the consolidation indicator 2, so that we can merge the records again. And one thing, if you want to send this record in the auto merge queue, like here you can see these all the records are queued for manual merge, right? This thing you can verify from merge manager. If you connect to merge manager, then here you can see your all the records are present here. So the records which will queued for manual merge, that record will be visible here. Okay, so if you want to change the flagging of this auto merge manual merge to auto merge, so we can do that. Let's try to find the option. Put on hold. So here put on hold, queue for matching, reset as a new record, accept all record without a match in the assignment list, without a match, cross reference table. This is the edit part. So match rule. Yeah, here we have the option. This is a flag for auto merge, right? So this record is queued for manual merge, right? Now if you want to send this record in the in the auto merge, so just click that record went for the auto merge. Now let's click for all the records, so that we can get all the records in the auto merge queue. So all the records went in the auto merge queue. That's why no record is visible here. Now if you come to database, so here earlier we had the auto merge indicator 0. Now if we refresh it, so now for most of the record it become 1, and for some of the record for why this is showing 0, because some of the record I think we had merged the record, so that's why we are getting some mismatch. Means two records had got matched, right? So that's why we are getting some 0, because that was already matched. So let's do one thing. Already we have found we have what we say match tokens, we have match records. So let's try to unmerge the records, because some of the records had got merged due to the accept all unmerged process. Here you can see, from here you can verify. If you are coming to accept table, so 1 2 3 4 5 6, here we don't have any merge candidate. Oh, so that record was single record, right? So that record don't had any match candidate. Now that's why we are not getting a multiple value object, right? What yesterday we are getting. So that record was single record, that's why for single that with the original row ID object will be the same, right? So that's why we are getting a one-to-one mapping. But in case of multiple, here we will get a same value and here we will get a different value. Yesterday we had seen, right? So now let's do one thing. Now let's clear this HMRG table, because here you can see 3 and 6 have got merged due to the uniqueness. So let me delete this record. We have the merge table. Now let's try to do one thing. Now let's try to run the auto merge job. Go to batch viewer, because we have sent the record to auto merge queue, right, from the manual merge. So we see this is saying that 4 record got auto merge, 2 record was unique, so that queued for merge. Now if you want to see that record, now come to data manager. Now reload it. Refresh it. So from here you can see only 2 record become only we can see there are only 2 records in the base object out of 6 record. So where the other record gone? So after running the merge job, actually we had seen like for one record we had many matches, right? We had many match candidates. So what happened? Like many record got merged and only single record become the master record for some group of records. So if you want to verify it, come to the except table. From here all the things will be cleared. So here we can see for this 4 record, the row ID object is 1. Here you can see this is 1 something, and here we are able to view the original row ID object. So after the merge, as we know that what the row ID object this record had, that will be stamped into the original row ID object, and in the row ID object column here we will get the master record row ID object column. So out of 1, 3, 4 and 6, this 4 record had we are matching each other. So out of this 4 record, after the merging, from here we can see one become the master record and the other become the loser. So how we can see one become the master record? Because from here also we can see in the row ID object for all these records are 1, 6001 something, right? So that's why we can predict that this is the master record. Out of the, after merging this 4 record, we got one master record. So for this 4 record, the master record is 1, and for these 2 record, the master record is 2. So here 2 and 5 got merged and we receive a master record as a 2, right? So from XREF all the things will be clear. Now if you want to see this information like which record got merged with which one, you can also see with the HMRG table. This is the merge table. So from here it is clearly saying this 6 got merged with 1, 4 got merged with 1 and 3 got merged with 1. So what happened? Suppose 3 got merged with 1. So maybe some winner will there will be some winner, right? Maybe suppose let's take 1 is the winner, and once this 6 and 4 got merged, so 1 become the winner in that case also, because in target row ID object we can see the 1. And again if 1 and 6 got at the time of merging of these 2 pairs, 1 again become the winner. So we can see here the merge pairs, like which record merge with the which record. So we can see this 6 merge with the 1, 4 merge with the 1 and 3 merge with the 1 and 5 merge with the 2. So here in target row ID object we can get the master row ID object. Like in your actual base object you will only have these 2 row ID object, 1 and 2. Let's verify it. So here you can see only 1 and 2 is here, because these are the master records. So this is the main purpose of using the MDM, right? If you have a millions of record, so in the millions of record you can get some lakh of records after running the merge job, because the duplicates record will be removed from this base object. That will be deleted from this base object. So where the information will remain for these records? So we will have the information in MTCS table, sorry, in the merge table and in the XREF table. So these two columns are very important to identify the merge. From here also we can identify the merge candidate like row ID object and original row ID object, and from merge table also we can find like which record got merged with which one and which become the winner. So target one is the winner and this record is a kind of loser. So if you are considering these two pair, so if these two record first merge, then out of these two record one become winner, this got loser. Then again the merge happened for these two record. Then in every case we have seen that one become the winner. So yesterday we have seen like why one is becoming the winner. Let's try to validate it. So we have not defined any trust setting here. You can see we have not defined any trust setting. So trust value is same for all the records, right? So how this is becoming the winner, like out of this 1, 3 and 4, why 1 is becoming the winner? So now let's go to XREF table and let's try to validate this 4 record. So you can concentrate on SRC LUD, source last update date column. So for this 4 record, here you can just see that this is 252, 45, yeah. So this is, what is the date, 26 October 16 something, 252, 252, 38. Just a minute. Sources are same. So this thing we can actually, I think I am getting some conflict here because with if you compare the last update is SRC last update date here. So I think this is the bigger value, right? Out of these two, out of this 4, 252, 45 something. So if you are considering this value source last update date, then this record should become the master record, like the row ID of original row ID object of this record is 6006 something. So we are expecting that this record should become the, so let's try to consider one record at a time. So this is the same record, that's not a problem. If you are considering these two record 1 and 3, so if you are considering this 1 and 3, then of course 38 will become the winner, like 3 will become the winner. So let's go to the HMRG and let's see the 1 and 3 pair. So in 1 and 3 pair, this is saying target as a 1. Let's come to XREF table, 1 and 3. So for 1 and 3 we can see the last updated. So here we can see the 3 is having maximum last updated, so it is conflicting something. So for better understanding, let's try to set the trust score. Actually what happens in a real case, if you are having the same value of trust score, then it will do look up for the source last updated and it will try to find the maximum source last updated and it will try to take that record as a master record in case of equal trust. So it is showing some wrong value. So sometimes it happens, means this is not supposed to be happen. Here we are supposed to get a master record as this record 6006, because 6006 is having kind of maximum last updated, right? So this record we are supposed to become the master record, what we are expecting, because all the 26 October 16 250. Oh, sorry. Here one thing you can see here, one thing we are doing the mistake. So for 6001 you can see this is a 54, right? Out of this 4 record, date part is same, but if you are comparing 252, so for 3 record this is 52, but this first record this is 54, right? So last updated is value is bigger for which one? For 1, right? That's why it is taking the master record as a 1. Actually I by mistake I was thinking that this is 252 for all the record, but here you can see this is 54. So logically, if your trust score is same, then it will have a look on the last SRC LUD column of the XREF, and from here it will try to find the maximum value of the last updated column and it will make the winner for that record. So here you can see this is 254, this is the maximum value out of this 4 record, and this is belonging from row ID object 1. Here you can get the actual row ID object, original row ID object. That's why out of this 4 record 6001 is becoming the winner, right? In the same way, if you compare this, we have 5 and 2, right? So why becoming 5, 2 is becoming winner? So let's validate it. This is 254, 24. This is 252. So 54 is bigger, right? So 54 is bigger, this is belonging from 2, right? That's why out of this 5 and 2, 2 become the winner this time. Fine. So merge has happened. Now we will verify this thing more clearly after defining some system and trust. Okay. So after merging, you can get the merge information from HMRG table. Here you can get the merge pairs, and also you can get the master record out of the one pair. And from XREF you can verify the group of records, like this 4 record got merged with this 1 record, and this become the winner. So from here also you can see the actual data. Like we have the, like if you want to see the actual data for one, what was the name and something, so here we have, right? From here you can see. Now let's try to do one thing. So this example we have done. So in this example we have taken one more columns of the other tables. Like we have taken a straight code which was belonging from the address table, right? So likewise this, in real case, if you have 10 or 20 or 12 tables which are correlating with each other, so just you can define these all the tables in a path, and you can select appropriate columns from the respective tables, and you can build a real-time match tools which can work up perfectly. So before confirming any real-time match rules, we need to do lots of POC, right? We need to take these columns, then we'll verify the records, like are we getting match conditions right or not. Also we need to take a different key width, right? So we have to spend lots of time for defining the match match rules, for confirming the match candidates. Yeah, any question till now?
So can you show me the final data, which table it is loaded after applying all this match and merge and tokenization? It will be in base table only, or it will be in what we will see?
Yeah. All the things we are getting, Lingamurti, we are getting lots of noise. So just I muted it. So see, as I had told earlier also, we are going to move to and fro of the base object table, right? So all the things will happen in base object table itself after the load. So here you can see only one thing is changing. After the consolidation, your consolidation indicator will change for this record to 1. That means this 2 record got consolidated. Fine. So record will be there, master record will be there in the base object. But how that will be distinguished with the other records? On the basis of consolidation indicator. Maybe on next day, if you are running some job, and if you will get some data, then that data will have the consolidation indicator 4, because the data will be the new record, right? You are getting from some source. So that data will have the consolidation indicator as a 4. Now if you run the match, then it will look for the 4, it will look for what we say. It will look for consolidation indicator 4 data, and it will generate the match tokens. Now it will again do some match and merge, and it will make a consolidation indicator 1 for some of the records. So likewise this means this cycle will be run on the daily basis if you have the load frequency on daily. So your main data will remain in the basis.
So in real time, so once the data is loaded in base object table, so again are we going to run this tokenization process and merge process you ran just now, right?
Yeah.
Multiple times you ran.
In real time, if our job load frequency is on daily basis, so we are going to repeat a whole process from landing to a stage. Like we run the stage mappings, we run the load job, we run the tokenize, we run the match, we run the merge. These all the process we are going to repeat on the same day.
No, while loading the base object table, we are applying the match and merge and tokenization, or after loading the base table, we are applying match and merge and again tokenization?
Yeah, after loading data in base object, then we are going for tokenization and match and merge. So first we need the data in base object. Then we will go for.
Can you go to batch viewer, please?
Yeah, let's go to batch viewer.
Okay. So what we did, we ran the data into, we loaded the data into base object table. After that, you ran this generate match tokens, right?
Right. So generate match token is not compulsory, but if you are defining some fuzzy match columns, then you have to run the generate match tokens. Otherwise, you can directly run the match job. So yesterday video you can see. From there you can get the detail.
Oh yeah, that's what I got confused. Maybe I will see yesterday
video. Please try to watch the yesterday video, then you can, I think all the things will be clear, because we are moving We are actually taking this complex example. So yesterday we had done the basic things.
Yeah, okay, maybe let's see to my study session.
Yeah,
Thank you.
okay. So yesterday we had seen a very basic examples. We had only one table, and on top of that table we had defined a simple rule. We had taken one columns. In today's example, we have defined two columns which are coming from two different tables, right? So in path we have added one more table. So in real time you can add many tables, like if you have a 10, 12, 15 tables, so you can add all these tables and you can select the match columns from the respective tables. So here you can see we are able to see only these two kind of columns from these two tables. So in real time you can select the columns from the respective tables, and here you can define the appropriate match rules, because once you are defining the match rule, here it is asking for which column you want to select, right? So you can select the columns as per your requirement. And one more thing I have to tell you here match purpose, so you have to select the as per your data, please try to select the actual match purpose, so that MDM will help you to find the right match candidate. So for these all the match purposes, some algorithm has been defined inside the MDM, and once you are firing any kind of match job, so these algorithms are running in the backend. So try to do the proper configuration as per your data. And here you can see one match label, that is typical, conservative and loose. Okay, so typical, that means that is most widely used in the real time, most widely used. So suppose you have got match tokens, so now MDA will try to search the record, right? So it search on the three bases. If you are selecting typical, then it will do the normal search. But if you are selecting kind of conservative, so it can select it can, if you are if with the help of typical, if you are getting suppose 10 match candidate, and if you are selecting conservative, then maybe that you could get less than match candidate as compared to typical. So in conservative, it try to do the comparison tightly, so maybe that you will get the less number of match candidates as compared to typical. But if you are selecting loose, that means it can find the more candidates as compared to typical. So you can see typical is a central logic. If you need a less match candidate, then you can go for conservative. If you need a more match candidate, you can go for loose also, right? So always try to keep in mind that here is a one match label. By default we do use a typical, but in some cases you are not finding a match candidate, then you can expand your searches after taking as a loose match label, so that it can generate more and more match candidate for you, right? But if you are getting your match candidate with the help of typical, it's fine. If not, try to do the POC with these match labels, so that you can get the right match candidate. Fine. So that's all. Here also you can see the search label. So that here the search label is something same. So here also we have a narrow, typical, exhaustive and extreme. So typical means let me open one theoretical part of this. So this part we have seen, typical, this part we are about to see. So that is narrow. So narrow means most stringent label in searching for possible matches. So if you are selecting narrow search, then it will try to find very less and less match candidates. So this is the means tight comparison will happen in the backend. So you will get a very less match candidate in case of narrow search label. If you are selecting typical, so this is appropriate for most of the rule set. So this is a generally, and we do use typical, because in typical we will get what we are expecting, like match candidate. In case of exhaustive, it's generate a large set of possible matches, same like what we see, like here we had something what we had, let's see this. Here we had something let me delete it. Here we had something conservative, right, or loose. So in loose we are getting more match candidate. We had in conservative we are getting less match candidate. So conservative is similar kind of narrow. In narrow we are getting less. Typical is same, and loose you can see like loose is similar to the exhaustive, because it is generating a large number of possible match tokens, right? And in stream generate, it will generate more tokens as compared to the exhaustive. So it is a still larger set possible matches. So it will take generate much and more match candidate. But yes, you can see we have a different type of search levels available. Like how we want to find the match candidate, right? So we apply some logic and we do some configuration in MDM so that MDM can work on top of that configuration. So we have many search levels available. According to our requirement, we have to select the appropriate search levels. Like generally we do use typical, but if you are finding like you are getting some wrong data due to the more candidates, then you can go for narrow. Or if you are finding that I am not getting the match candidate what I am supposed to get, so you can extend your searching and you can try for exhaustive and extreme search levels. So these all are the theoretical parts we had. Yeah, here also we have enable filtering. So here if you want, you can enable filter and you can apply filter something if you want. Here we have the primary key match rules. So yeah, before that, let me show one more example. What the example we had planned to see. So let's define some trust setting, right? Because that was our in the first class, in the demo class. Let me open it. In the first demo class, so in the first demo class we had seen like this was the example, right? For this record we are getting some trust score, right? For this record we are setting some trust score. So let's try to complete this example in the practical. So now let's try to set some trust score, then we will be able to identify the records. So if you want to observe the differences, so at least we need to get data from two source system, right? Because if you are getting data from only single source system, then you will not be able to verify like which is becoming the master, like which record is becoming the master record out of two records. So let's add one more stage table for employee. So let's say SEMP and this is SRC2. Let's select all the columns. So we have added one more stage tables. Because why I'm adding one more stage table, I want that I want the data in base subject from multiple source system. Then I will be able to identify like from which source system data is becoming the winner, right? And then we will also define some trust score. Now go to mapping and let's define mapping for employee for source system 2. Mapping for employee for source system 2. Mapping for employee, let's landing table of mapping and source system of source stage table of the mapping. Let's do auto mapping. Let's connect this EMP ID with the PKSRC object, right? And here we need to add one more column. We need to filter the data from different source system, right? So let's go to a schema. Let's go to employee table. Here let's add the source system column. So let's add a source system. Now let's apply the filter in the mapping. So we have this mapping for employee. So let's go to filter, apply like source system equal to SRC1. Let's validate it. Let's save it so that in SRC1 stage table we can only get the data from source system 1. Let's apply the same filter in this mapping. SRC system equal to source system 2. So fine. So now we have defined the appropriate mappings. Now let's go to the landing table of employee and let's add some sources. Like this is coming from source system 1. Let's see. So here let's delete multiple records, otherwise you will not be able to identify. Let's only keep 2 records so that we can find which record is becoming the master or not. Let's make this record is coming from address ID 2, and this record is coming for source system 2. So we have 2 records. One record is coming from source system 1 and second record is coming from source system 2. That's configuration we are doing. So let's truncate our base object tables. So in real time you have no need to truncate this, because as you know that base object is not a truncate load, so some update and insert will happen. strp mtch hmrg. Oh sorry, you are seeing the wrong tables. So strp. So we have not changed the what we say match rules, right? So that's why that need to be truncated manually. This match table is cleaned, as we know that after running the merge job, this match table will be truncated, right? We need to. So here you can see we had enabled the history for employee, and all the records are maintaining in this employee history table, right? So if you want to backtrack any record in future, so you can backtrack all the records. So here we have all the row ID objects and all the records. Here all the records row ID object are here, you can see. Okay, so you can enable the history if you want to preserve the history, but keep in mind that it is a very cost performance effective, so it will take lots of time to run the job and the storage. So if required, then you can enable the history and you can keep the history of all the records. This is clean, this is clean. Let's clean this HMRG. This is clean. Yeah, now it's fine. Now also we had created some test data, one for source system 1, one for source system 2, right? Now let's run the stage job for employee so that we can get the new records, fresh records. So do we have matching records? So this may or may not match. So let's keep this as only Sujit. This is the test data we are taking. So now go to batch viewer, go to the stage job. Here is the stage job. This is the stage job. And let's run the stage job for employee for source system 1 first. So I think 852, yeah, this is the record. So we got one record. Let's verify it in the stage table of employee source system 1. So here is, yeah, this is the stage table. So here you got one record which PKSRC object is 100 and its ADR address ID is ADR1, MP ID 100, right? Now let's run the second stage job. Let's run this one. So we again got the one record that is expected. That record, because only we had created a single record. So we got one more record which is having the address ID 2 and MP ID is 200. Fine. Now let's so before running the load job, you have to configure your trust score, because you know that trust calculation happens on the load process itself. So if you run the load job and if you will define a trust setting after that, then trust calculation will not happen appropriately. Okay, so before running the load job, first define the trust configuration appropriately, then run the load job. So till now we have not configured any trust setting, so let's try to configure the trust setting. And here you can see you cannot see any columns, right? Because we need to enable some columns from here, from base object. So let's come here, let's click here, let's select only EMP name columns, because EMP name is different. For one record this is Sujit and for other record this is Sujit Patel something. So let's try to define a trust score on EMP name. Now come to system and trust. Now here you can see the BMP name column of this BMP table. So why we are able to see only what is a source 1? Why we are not able to see source 2? Let's try to debug it. Because we have the stage table. We have two stage tables, so we are supposed to get SRC1, SRC2. So why we are getting only in system and trust? We are getting only SRC1. Here also we have defined source system 1 and source system 2, right? So let's try to debug it, like why we are getting only SRC1. Admin is default, right? But we are supposed to get SRC2 also. But why we are not getting in the system and trust? We have two stage tables. Is there any difference we have? We don't have any difference, so all the things are same, right? Let me pause the recording. Yeah, so what the mistake we had done, see here you can see for this stage table also we had taken the source system 1, right? And for this stage table also we had taken the source system 1. So MDM is understanding that both the stage table is picking the data from same source system. So let's delete this stage table and let's create the stage table again. So this mistake we had done. Here you can see also, I think if I am changing this SRC2, so in this stage table contain data, please verify the data in both the system and delete the record if no longer appropriate. So I think if we have the data, then I think it will not allow, or it may delete the data. So now we have saved to SRC2. Now if you come to system and trust, so now here you can see source 2 is visible, right? So that mistake we had done, like at the creation of stage tables, for both the stage tables we had taken the same source system, SRC1 and SRC1. That's why SRC2 was not visible there, right? So fine. Now let's check a stage table, like do we have a data in a stage table, or it has refreshed the data because we have changed something. So we have the data, and also we have the data here. Fine, perfect. So one thing we may receive, yeah, we have already changed the source system too. Fine. So now let's try to define a system and trust from these two different source system. So let's give some random value, like for employee name, for source system 2, let's give a maximum value as a 90 and a minimum value let's give as a 80. We are giving just test value for doing the testing, and we are defining support, let's take for 12 months, and we want like slow initial rapid later. This thing already we have covered, right? And for source system 2, let's kind of 80 and minimum value let's take 70. We are defining for 12 months, and for this we are taking slow initial rapid later. For administration we always give a highest value, let's give 100, and let's give minimum value as a 95. For admin source system you always take a means higher trust value, right? If you are getting any data from admin, then we consider that we are getting the right record. So how we get the data from admin, we will see that. Just now we'll see that. So let's configure for 12 months. Let's take slow initial rapid later. Let's save it. So now this trust configuration we have done, right? From source system 1 we have given this trust value, for 2, and for admin we have given this, right? So why this is not saying anything? So invisibility, that is creating some problem, but it is taking value. Here you can see, right? So for source system 1, for source system 2, and the default admin source system, we have defined the trust score from the 3 different source system. So now if you will run the load job, then respective trust calculation will happen on the base object record. Before moving the record to the base object, respective trust calculation will happen. So before running the load job, please check that you have defined trust score clearly. Now let's run the load job. So let's check. I think we don't have anything in the base object already. We have cleaned the data. Nothing and nothing. Fine. Now let's run the load job. Go to load procedure. Load job for source system 1. Execute it. So now it is saying one record got inserted. Let's check that record. So we got this record, which is having consolidation indicator 4, new record, and EMP-ID 100, this one, right? Fine. Now let's check from cross reference that what source system this is taking for this record. So for this record it is taking source system 1. So that's fine. Now let's run the load job for source system 2. This one. We again got one more record. Let's verify this record from cross reference. So that record is coming from source system 2. That's fine. And here you can get the name like this, address like this, and address ID is this, right? So finally we got the 2 record in the base object. Now let's verify the trust value of this record, because we are telling that after running the load job, trust calculation happens. So go to data manager, and from here you can see the trust value. So here you can see for name field, for employee name, for source system 1 record, here you can see this is a base object record. So we have selected 7, like 677 something. So this is coming from source system 1, right? For this we have employee name Sujit, and for this we are getting trust value 80. If you are selecting second record, which is coming from source system 2, for that we are getting trust score of 90, right? So that value we had given in our system and trust. For source system 2 we had given 90, and for source system 1 we had given 80. So in real time, in some cases you can get some decade value, like you can get like 79 point something, 78 point something. Okay, so don't worry for that. So what happened is a training environment, so we can get some decay. So MDM will understand some decay has happened, so that's why you can get some less value in some cases. Now here we are getting exact value, but in some cases you can get some small decay value. So don't worry for that. So here we got the exact trust calculation has happened, right? Now first let's try to run the tokenization. Before match we need to generate the match tokens, right? So go to batch viewer, go to generate match tokens, generate match tokens for employee, execute batch. So 2 record got tokenized. Let's verify this record. Go to strp table, and here you can see for this this was the bigger string, so we got 2 match candidate, and for this we get 1 match candidate. Sorry, one token, not match candidate. This is tokens, right? We have generated the tokenization. Now let's run the so we need to see what is the so till now we have not executed what is a match job. So let's see. Okay, let's check the match job for one time. Go to schema, go to match setup. Let's verify the match rule. So in match rule we have taken auto as a no. So this record will go in the manual merge queue, right? This will not go into the auto merge queue, right? No issue. So let's get this record in manual merge queue, and we will try to merge this record from merge manager this time. So we have done the tokenization. Now let's go for match. Now let's try to find the match candidate. So let's run the BMP job. So here this time we did not receive any match tokens, right? Why? Because see, our 2 records are different. Here our 2 records are different. So this time what the so here we have taken SUGIT. So here let's take SUGIT, then we can get some match. So that's why there is a big difference between the 2 record. That's why we did not got any match tokens, right? So let's edit the record. And now let's verify the record from data manager, that are we getting the edited record or not. Go to data manager, let's reload it, and for this is Sujit, that's fine. And for second, this is again showing Sujit Patel, SUGIT Patel, this is showing. Let me refresh it. So for this is same. For this is saying the old value. So this time this time we may not receive the match tokens, right? So let's do one thing. Let's regenerate the match tokens. So before that, here you can see the consolidation of record has been changed to 2. Why? Because just now we have run the match job. So after running the match job, you know that consolidation indicator will change to 2. So we have to make this consolidation indicator 4, so that we can regenerate the match tokens. So how can make it 4? So go to data manager, select any record, go to flag and set as new record. So here you can see consolidation indicator change to 4. Let's change the consolidation indicator of this record as a new. So here you can see both the records are looking like a new record, right? Now let's generate a match tokens again, and let's see that what the record we have edited, are we getting a right kind of match candidate or not? Because this time we were getting this type of match data, no? So go to batch viewer, go to generate match tokens, run this job again. Here select this regenerate all match tokens, so that it will regenerate the match tokens. So to record tokenize, let's verify the strp table again. So we got the same number of tokens, 2, fine. Now let's run the match job again. Previously we did not receive any match. Now let's run the match job again. So this time we receive one match candidate, because now the two names are kind of similarly matching. There's a slight difference, right? So that's why we are getting the match candidate this time. Here you can see. So here is the match candidate. So this record and these two records are matching. MDM is saying these 7 and 8 are matching. So now you can go to database base subject, and here you can see 7 is this and 8 is this. So these two records are matching. So here you can see the consolidation indicators changed to 2, and where that record is queued is in manual merge or in auto merge. So here you can see auto merge indicator is 0. That means that record went into the manual merge queue. So how to see the record which are there in manual merge? Go to merge manager, select appropriate tables and packages. Here you can see both the records. Okay. So for this record, this is saying this record is matching. For 7, 8 is matching, and for 8, 7 is matching, right? So in merge manager we have 3 segments. Here you will get the base subject record, here you will get the match record, and here we will get the what we say. See here one beautiful thing we are able to see before running the merge job. So here if you are clicking on this record, so 7 is saying that this 7 is matching with 8. Which 8? Yeah, this row ID object 8, right? And if you come here, so this is giving the compared comparison value. Like this is for this record is for 7. Here you can see this is 7, and this record is for 8. So these all the columns are giving the information about 8. These all the columns are giving information about 7, right? So if you see on the employee name, the trust score is 80. From here also you can see the trust score. And for 8, this trust score is how much? This is 90. From here you can see. Here you can see the trust score, right? So the record here you can see this record is showing in a bolder as compared to this, right? So that means this record is going to become the, let me refresh it. So that means this record is going to become the master record. If the record is showing more bolder, that means that record is going to become the master record. And also the trust of this record is high, right? So after running the merge, we are supposed to get the 8 as a master record, and 7 will be deleted from the base subject. That's what we are expecting, right? So now if you see that we have 2 records in base subject, 7 and 8. But from merge manager we can see 8 are supposed to become the winner because it is having the higher trust. Now let's run the record from the merge manager. How to merge the record from merge manager? Go to here. Here you can see this is a merge the record, merge the unmerged record with the match record. Let's click on this. Let's press yes. merge was successful. Now you can see out of 2 record, only 1 record is there in your base subject. So now if you see refresh your base subject, so only 8 is here. So 7 become the loser, right? And 8 become the winner. Why? Because we had seen that 8 had the higher trust value, right? That's why that become the winner. And if you come to XREF, from here you can verify 8 has become the winner, and 7 was participated in match. And also if you want to see the merge candidates, so here you can see 7 and 8 got merged and 8 become the winner because 8 is there in the target value object, right? So after defining the trust score also, we verified that MDM is finding the right match candidate, and NDM is comparing the trust score of the records, then it is evaluating the master record. But if you not define trust score, then MDM will treat this trust score value same for all the records, and it will try to see the value of last update date, and on that basis it will try to find the master record, right? So that's all for the today's session. Let's stop this session. So in today's session we saw the one better example of what we say of match and merge, and we also done the merge from merge manager, and we saw one more complex example of match rules, like we combine 2 tables, one parent and one child. So likewise you can combine many tables in real time, and you can generate a more complex match rule as per your requirement.